Hi, everyone. I'm Nick Siegler. I'm working at NASA's Jet Propulsion Laboratory, and I want to share with you a little bit of a side job that I've been doing for the last few years with collaborators from UC Riverside and elsewhere. And it's called the NASA Technosignatures Survey Database. It's something we've been working on for a few years, but we finally got it to the point where we look like we have some early results, and I'm excited to share them with you. And some of them may even be important. All right, so NASA's search for life has mostly been focusing on habitability and biosignatures. If you look at our own planetary, our own solar system, we all know that there have been rovers roving on the surface of Mars. We've had landers. We have even sampled asteroids. We've had orbiters orbiting around Saturn, Jupiter, Mercury, Venus, right? And so we've collected a lot of data. We're excited about the Europa Clipper that will be orbiting Jupiter and sampling the upper atmosphere of Europa. And then outside of our solar system, we have these large telescopes. In fact, we're dependent on telescopes, right? So Kepler, James Webb, and we're anxiously excited for the Habitable Worlds Observatory. These missions are expensive, and more importantly, they take a long time. And there's a long time in between these missions. So I couldn't help but thinking in my role in the Exoplanet program at NASA, well, while we're waiting, what about the search for technosignatures? Technosignatures are clearly a subset of astrobiology. So I started asking the question, is there anything more that NASA can do, besides the obvious funding, but is there anything more that NASA can do regarding advancing our community and helping look for technosignatures? So again, about 4 years ago, we kicked off this NASA Technosignature Survey Database at one of Jason Wright's, I think it was his first SETI Symposium. And so the purpose of it is essentially, it's a fact-finding study to inform NASA where it can make a positive impact in the investigation of technosignatures. I wasn't exactly sure where it was going, but I know NASA responds very well to objective, clean, landscape fact-finding studies. But essentially, now that I've been in it for a few years now, it looks like it's going to become, I think, a wonderful community resource for enhancing the search for life investigations through technosignatures. All right, what does this database look like? Well, essentially, we're collecting every possible technosignature that you, the community, have identified through peer-reviewed literature. That's obviously the admission price. And also, along the way, we've been collecting all the different investigative approaches to look for those technosignatures. And as you can see in this illustration, there are more than one way to look for a particular technosignature. So we've been capturing all of those. And then on the horizontal axes, we have 31 data fields. We obviously describe the technosignature. We describe the investigative approach. What wavelength is it operating at? Or maybe it's not a wavelength. Maybe it's a particle. We're collecting what current, future, and even past facilities, ground-based and space, are able or can be able to conduct this investigation. As a technologist, I'm also interested in what technologies these investigations need. Maybe they don't need anything, or maybe there's some type of synergistic technology that could be helpful if we knew what they were. And then I'm using the word ambiguity here as a reminder that we captured the 9 axes of merit that Sophia Sheik had written up, I think back in 2020, I think it was. And that is very helpful to try to gauge which technosignatures may be more valuable than others, or which investigation approaches are more valid than others, or more viable than others. So we have all 9 of them in here. Ambiguity is one of my favorite. If you were up this morning early, you would have heard about duration as being another one. And then, of course, the citation. So this database is pretty full with a lot of information. We hope at the end it's going to inform new and active investigators, like some of you listing right now. We know the public loves this, educators love this, so I really wanted to handle this in a very sophisticated and a scientific way. And then, let's face it, philanthropists could make a very big difference, and the database is structured for them to assess as well. Some of the questions it'll be able to answer: which current observatories can search for which technosignatures? I'll say more about that at the end. And which technosignatures have never been investigated? That leaves some fertile ground to be investigated. And then if there are questions about what are the top scored technosignatures and why, they're also captured in this database, and a lot more. So let me share with you some preliminary results. I've been waiting to get to this point for a long time because I've been advertising the work, but now we actually have some results. And this is just the tip of the iceberg because we just got to this point. All right. Drum roll. I went into this thinking that there were maybe a couple dozen technosignatures, but it just shows my ignorance. We're up to 41, and that's absolutely a lower limit. There are more all the time. To break them up into categories, we have found 5 artifacts. Things like on the surface, but artifacts also beneath the surface, believe it or not. Aliens are expected to travel, so we have several focusing on that, like the exhaust of rockets and the UMA equivalents. The bread and butter of our community has been searching for direct intentional communications, radio and lasers, so I wasn't surprised of those. But what I was surprised is how many megastructures and civilization activity ideas this community has come up with. They obviously dominate the total number of technosignatures. And so civilization activities are things like heat islands, artificial illumination, industrial gases, things like that. So that's the distribution. The range of the technosignatures extend from the well-known, like what we just heard from the first 2 speakers with radio, and then in the visible and near infrared, both spectroscopic and photometric lasers, and then surface artifacts. Those are the ones we all know, but the reason that I think we all love technosignatures and this community are the creative ones. I'm just astounded at the creativity. Things like, well, alien spacecraft exhaust from maybe annihilation reactions, anomalous sequences in genomic databases. That is actually a paper, folks. Aliens could be trying to communicate with us through gravitational waves and anomalous planetary system. Sean Raymond had a really interesting paper about if you see multiple planets in a transit that are in the same orbit, that could be interesting. Now, one of the interesting observations we've made is, back to the bread and butter of our community, these 2, they largely are based on ET intentionally trying to communicate with us. And so if you don't subscribe to that hypothesis, or in the dating app of the galaxy, if the aliens have identified us and then swiped left, well, then what do you do? And so I was very curious to see how many of the technosignatures don't rely on intentionality, but perhaps are unintentional. And I had no idea what to expect, but I was surprised to see that of the 41, 73% of them are unintentional. And that could be interesting, right? That could lead you to other types of investigations. And another 7 were both. I acknowledge that radio can do both unintentional leakages and intentional communication. But here are the ones that, I think these are most of them, not all of them, that are unintentional. And you'll recognize things like artificial illumination on the surface of a rocky object in our solar system, for example, or maybe an exoplanet, heat islands, Dysonian objects, industrial pollutants, solar system lurkers, spacecraft exhaust, and a bunch of others that you'll recognize. So again, this might drive you to giving these a little bit more attention. Now, how many ways are there to search for these 41 technosignatures? Well, we're up to 112 and counting, and that number blew me away. Again, radio made up only about 5%, despite the fact that it's about 95% of the overall community effort. But you can see how many ideas are in the visible, but they span the entire electromagnetic range and even some non-electromagnetic concepts. I was happy to see that 61% can be done from the ground because they tend to be cheaper than those done in space. I was also happy to see that we're looking everywhere. We're looking within our solar system, around our sun, and then in the galaxy and extragalactic. And we're also seeing that more of you are identifying AI-led archival searches. AI has bubbled to the top of one of the best capabilities. That's actually happened just obviously recently. And so that is already mature enough to start doing a lot of interesting things. So these are some of the statistics that came from it, but let me share another one with you. 112 different ways to look for 41 technosignatures, but how many of them have actually been conducted? I was surprised. I don't know if you are, but out of 112, only 28. And of course, the varying completeness. I think I can go on record and say none of them are complete. Right, there's so much more to do. And so here are the type of technosignatures that have been the target of the ones that have been conducted. So you'll recognize almost all of these with the line of sight, radio and visible being the most common. But then Dysonian objects, exobelts with transiting photometry, looking for lurkers within our solar system. These are all things that are possible. So again, this is interesting, but the fact that the number is so small may motivate some of us, or maybe new investigators, to take a look at the ones that haven't yet been investigated. It's fertile ground. Another little factoid is of these 28, 15 of them, if they were successful, we would declare that detection is unambiguous. And I point that out simply because for those of us that traffic with biosignatures, we know that's not the case. We know that there is a struggle of, is it an abiotic source or not? And with these 15, and there's probably more, the detection is unambiguous. Congratulations, you are on the cover of the New York Times. All right, so I've given you some factoids. Let me throw one more at you. How many technosignatures can be observed commensally? So commensally in this context means you're piggybacking onto a more traditional astrophysical investigation. So someone is observing with Hubble, and they also decide that besides looking for maybe supernova, they could also look for technosignatures, something like that. And the answer is 71% of that 112 can be done commensally. So that to me is striking. I think we all know and we all have done some of this, but the fact that it's so high leads me to believe that maybe we need to do more of an outreach effort amongst us scientists to remind people that while you are not maybe a card-carrying technosignature scientist, you could be. More things that this database can answer. You can ask it which technosignatures might reveal large cities and industries or infer them on exoplanets. You type that into the GUI, and boom, all these things will come out, right? Things like pollutants in exoplanet atmosphere, that's a whole new cottage industry. It'll even tell you that you can do it through transit spectroscopy, reflected light spectroscopy, emission spectroscopy. It'll tell you what wavelength, so you know if the telescope of interest has that capability. And then you'll recognize some of the other ones like heat islands and artificial illumination, narrowband emission from artificial lighting, etc. Now, here's probably, to me, I think one of the most important questions this database can answer, right? Which technosignatures can the blank telescope investigate? This is one of the spin-offs, I think. So you're an astronomer, you're about to write a proposal to the James Webb Space Telescope, and maybe if this database becomes available, and I hope it will be, you'll be able to punch this in, and then boom, out comes all the possible investigations that this telescope can do. Now, I didn't say that You'll get time, right? That's always the big challenge, but at least now you know what is capable. As a scientist, you have to figure out the sensitivities and how many observing hours you're going to need. It won't do that for you, but it'll definitely tell you what is possible. And it's not just space-based, it's also ground-based. And obviously, we're all excited about what Rubin can do, and I suspect that this list is incomplete. All right, so let me wrap up. Next steps. So as far as I'm concerned, this database is ready for prime time. I need to develop, well, first of all, I have to host it. And so I'm leaning towards where the NASA Exoplanet Archive is. That's at Nexi, at IPAC at Caltech. They've graciously said that they would, but they haven't seen it yet. So I'm in the process of negotiating with them. I also need a GUI, and I'm going to go out on a limb and try to get some help to write a natural language model so you can just investigate the database with natural language. Yes, I will have very strict guardrails, but I want to give that a shot and see how that works. And then how is this thing going to be maintained? This community is so darn creative that there's, I don't know, a few papers that come out every week. And so I'm looking at an AI agent to scrape the papers that come out, compare it to the database, and make recommendations of what should be changed. And then a human in the loop will accept it or not. I hope that I'll go live sometime this year. That's the intention. And then I want to go on a publicity campaign so I could encourage people, inspire people to do it. And it's not just us, but it's also those who are serving on allocation committees to acknowledge the fact that maybe there'll be more investigators in the future wanting to append a technosignature investigation, and we don't want them to snicker at it or think that there's scope creep, that this is one easier way to increase the number of investigations. How can you help? First of all, I think I want to ask you, how do we enhance the conventional investigations, right? There are a lot of smart scientists out there who don't even know that they could. And so I'd like your thoughts on how can we share that with them. And then if you'd like to help me fact find, there's a lot of cells in this thing, and I won't claim that they're all correct. So I would love to have some fact finders. And I'd love you to also beta test the data set with the natural language model. Go ahead, ask it whatever you want, and see if the information that comes out is useful and appropriate, of course. If you want to reach out to me, there's my address, and I look forward to your feedback. Thank you.
All right, thank you so much, Nick. Really great to see those results. That's very, very interesting. And so we now have question, answer, discussion time. So first, a very quick question for Nick. I think we should answer right away. Who input the data into the database? Andrew Frackman wants to know.
Yeah, right. So my team at JPL started. I roped in several scientists to start off with, but it's just such a yeoman's effort, right? And so I actually wrote a contract with UC Riverside. Some of you know Eddie Schwieterman, and he has a brilliant young grad student, Evan Sneed, and they worked on it for an entire summer. They've rolled off, and now I'm just kind of polishing it off here and there. But I think it's good enough, but I'll keep playing with it. But once it goes live, I will accept any suggestions from the community of errors or new discoveries or needs, and I'll update it for as long as I can before I hand it over to someone else.
And then Abel Mendez asks, how many biosignature types are there for comparison with your results?
Oh, goodness. How many biosignature types are there?
Or at least how would you compare sort of, the fraction of technos,
Yeah.
You've analyzed technosignature types. How would you kind of compare that with biosignatures?
Yeah, I haven't done that. I imagine there's not many. Jacob, you traffic in that world. What do you think?
I mean, that's difficult. Sarah Siegler gave a talk at this meeting earlier about technosignatures and, the diversity of possible molecules. And she's done that work, which she alluded to with biosignature molecules. She has a huge laundry list of possible biosignature molecules. Um, but I would say, is that because there's more options for biology than technology, or is that because we've been thinking about the options about biology longer than the options for technology? And then I also like the conversations about how this is a spectrum. I think of technosignatures as a subset of biosignatures. It's all biology. It's just what is the biology doing? And so I kind of agree with that. So that's not a satisfying answer. I don't know. Like the fluorine compounds, are those always technological or mostly technological or just on Earth? They're unique, but so I don't know. But I like the percentages that you have and intentionality or not and things like that. I think analyzing that, maybe Abel has suggested a good student project for the future.
But more importantly, it's really hard to get biosignatures, right? And probing the atmosphere of exoplanets is really hard. It needs to be done, and habitals will play an important role. We're going to need a mid-infrared interferometer at some point to get the other part of the spectrum, but they're really hard. So I want to make contact in my lifetime, and unfortunately, biosignatures might take a while.
So we don't have any more questions in the Q&A, but Jill posed, I think, an interesting question. There's been some follow-up in the chat, but I think this is worth posing to the whole group. Did any of you get up the courage, she asks, to define when enough is enough to draw a negative conclusion? And I'll just add one thing. You can take this however you want, and it'd be great to hear from all the speakers who want to answer this. But I mean, I think this could be you draw a negative conclusion about, we are alone everywhere. But then, I also think I see these great papers on the archive. Jean-Luc posted a bunch of them with the students where you search one system or a number of systems. And so, perhaps if we're still open to, maybe we're not alone, we haven't searched the whole universe enough. Maybe when have you searched individual targets enough that we could say that's enough. So there's the question posed to anyone who wants to answer.
Jacob, I want to acknowledge that there were about half a dozen really insightful questions in the Q&A. So thank you for the great questions. I've tried to answer them online. If there's, I can provide more if no follow-up is needed. And I do have 2 other slides to show if we have time.
Sure. We have plenty of time for discussion. Yeah.
This is a little bit off topic.
Wait, are you going to answer her question?
Oh, I did I'm sorry. I did in the chat.
Oh, for Jill?
Yes.
Oh, did anyone else want to answer her question?
Go ahead.
Well, I was just going to say the obvious is we are never going to give up simply because we know statistically there is life out there, right? And we all know that in our bones. So it's just a matter of developing the right investigation with the sensitivity and getting lucky. So I don't see that threshold from my perspective.
Yeah, so my answer to Jill was that the search volume is so large that we've probably only scratched the surface, and that before giving up, I would like to see something approximating an all sky, all the time, all wavelengths kind of monitoring system, and we're nowhere near that point. I did want to thank the organizer, if I may, Jacob.
Yeah, go right ahead.
I think this meeting has been absolutely wonderful. The talks, the interactions in the Slack. And to me, that speaks to the fact that I think the IAU is a really good home for SETI. Most people engaged in the search are astronomers, so the IAU seems like a good home. And I'm going to express the opinion that, to me, the International Academy of Astronautics is not, and that's primarily because spacecraft builders do not tend to do SETI. astronomers go to IAU meetings. They don't tend to go to IAC meetings. Most of us don't. And then there's the cost issue, right? You can go to the IAU meeting for 600 euros, whether you're a member or not, and membership is free in the IAU. Whereas in the IAC, you're going to pay 2.5 to 3 times as much, and membership costs are high. So the IAU has a commission F3 astrobiology that includes SETI as a scientific field. And the IAU also has working groups that are relatively easy to set up. And so I'm hoping that maybe out of this meeting, a working group geared towards SETI could come out of this meeting. The IAU is a big tent. It can welcome anyone doing SETI research or SETI adjacent research. There's categories of membership for individual, junior, or associate members. You don't necessarily need to be an astronomer. So, it could accommodate all the SETI adjacent research. And then when I bring this up, the obstacle that I get all the time is, we've invested so much in the IAC and in the IAA, and it's hard to change. But that, to me, sounds very much like the sunk cost fallacy, where you look at what you've invested in the past, when in fact what you ought to be doing is looking at what is the best solution for the future for the development of SETI as a discipline. And so that's my plug for the IAU. I hope I see more SETI in the IAU. I think it's a great home for it. And I want to thank the organizers for this wonderful meeting.
No, thank you for that. That's a great idea, and we will. I'll follow up with you on that. I like the idea, and it doesn't have to be an either or in my mind.
Sure.
I don't think anyone calls me early career anymore. If you do, I'll be flattered. I'm not. I still don't have too many grays here, so whatever I am. But the sunk cost fallacy is not a concern for me. I'm a latecomer to some of these things, from the people who, were the ones who were the trailblazers and formed these communities. So I think more nexus points is good. I like, these post-detection hubs that are forming. I don't think we need one. I think we need several. And so I don't think there's a problem with having multiple places for SETI researchers to go. Which one is the main place? That's sort of almost an evolutionary outcome. We'll see, whatever people congregate around. But no, I appreciate that. That's a great feedback. So so there's something okay, we have a bunch in the chat now, or in the questions. Great. So yes, we need the answer for funding, absolutely. But question for Nick Siegler. How granular are the individual technosignatures? It seemed on one of the slides that leakage and deliberate transmissions were lumped together. But if I might consider a beacon, planetary radar, leakage distinct. To compare with biosignatures, do we consider all molecules an individual type or just entire classes of molecules? Nick, you're muted.
That's a very fair question. So when I architected the database, the quantum unit or the granularity was the instrument on the telescope, because I was thinking of the person that proposes, right? And so if you're interested in industrial pollutants in the mid-infrared, you could consider James Webb, but you wouldn't think of Hubble, right? And if you want to probe the atmosphere of exoplanets, then you need starlight suppression. And so it was to that level of granularity that you need an instrument that can actually detect it. And so for industrial pollutants, we would have that as one technosignature, but it could have maybe 4, 5, 6 different ways of getting to it. Each one is a different instrument because there's a data field that asks, what is the technology needed to conduct that investigation? And obviously, the different wavelengths are going to drive the technology. And sometimes those technologies exist and sometimes they don't. And if they don't exist, then I capture that as a potential gap and a flag to whoever wants to invest in it. But it's also revealing to the community that it's not there yet. So don't get your hopes up until it is. So I'm not sure that answers the question, but that was the level of granularity that I had in mind.
Um, let's say, I guess, related question from Mark Elowitz. How does the Technosignatures database deal with what would be considered simultaneous biosignature and technosignatures? Some things could be both at the same time.
Yes, exactly. So there's another data field that's called ancillary science. And that's the one that I would expect someone who's interested in biosignatures go ahead and type in biosignatures, and out comes all of the technosignatures that can be conducted during an investigation of biosignatures. Or you type in supernovae and out comes. So that's how it was intended to be helpful.
So it looks like a comment from Abel Mendez. To frame the search as positive, we shouldn't say that we still don't know whether life exists elsewhere. Instead, we now know many places where it does not exist, at least within the limits of our current detection capabilities. Right. Yeah. And then Jill says, okay, well, the IAC is important to convince space manufacturers to practice spectral hygiene. Right. That's good. I suppose. Although, yeah. So Kenneth Houston, how do we get more electrical engineers and communication experts involved in radio SETI? It's a communications problem, and we need more input on waveform types and modulations to drive SETI search strategies. That's for anybody.
Yeah, so that's a great question, and it's really important. As part of the UCLA SETI course, we've been thrilled to have electrical engineers, computer scientists join astrophysics majors, and it's that combination that really makes it exciting and a strength of the course, I think. So we do have electrical engineers who take the course.
All right, we are out of questions. You raising your hand, Nick? Say something else?
Old school, analog. What do you think?
Yeah.
Yeah, I just wanted to say one thing. See, hopefully I didn't have a senior moment and have forgotten it. Yeah, I wanted to share something with everyone. One of the best things that could possibly happen to our community is having a member of Congress put language into some NASA appropriation bill saying NASA should do more technosignatures. And that actually almost happened back in 2017 when there was language from a congressman who was asking NASA to spend up to $10 million on technosignature investigations. Unfortunately, somehow that didn't make it to the reconciled bill, and that fell away. But in anticipation of that, the NASA division director at the time didn't have a great answer of how NASA would undergo that type of investigation. And he did the next best thing is he launched a conference, if you remember back in 2018 in Houston. Our own Jason Wright and Dawn Gelino led that. A really nice paper came out of that. And that paper has influenced some of my work. And so it would be great for that to happen again. I obviously cannot lobby Congress, but if one of you wants to, that would be very helpful. But the next best thing is something that actually did happen. And that is folks petitioned the NASA Astrophysics Division asking for what we call a science analysis group, SAG for short, a science analysis group. And that group was approved by NASA to study how technosignatures could play a role in search for life, what are suggestions that NASA should consider. And so that group stood up. It's probably been a couple of years already. It's led by Sophia Sheik, but I think it's reached out to, I think the entire community is somewhat involved in this. And that report should be coming out this year. And that's really exciting because NASA will listen to an analysis group that they stood up. They may not listen to me, and they may not listen to Jacob, but they will listen to an analysis group. They're not required to execute anything they recommend or suggest, I should say, but they will certainly listen. And so I think Sophia and Jason are part of this, and Ravi. I think it's going to be a very sober report, but with a lot of really good suggestions, and I hope NASA will take on some of them.
All right. Thank you for that update. Excellent. All right. Any Other last, I see something in the Q&A. Oh, it's, Jill says talk to the staffers. Yes. The ones who do all the work. Right.
But their shelf life, their half-life is not very long, Jim.
Any final either questions from the attendees here or final thoughts from our speakers? Anything you want to leave us with? Been a great conversation already, plenty to think about. So
there was a question from or comment from Jill about spectral hygiene with spacecraft builders, and just a few weeks ago, Chris Dupre at NRAO described a wonderful system that coordinates with SpaceX constellations to turn off their transmissions when the VLA or the GBT is pointing in that direction. As far as I know, this was all done without the IAC. It was all done through direct contact with SpaceX.